I'm Anil Kumar sharing with you few concepts about absolute function which are very important for students taking functions and pre-calculus courses. We are going to discuss all these topics in this particular video, and in part 2 we'll take a few examples based on absolute functions, equations, inequalities and double inequalities. You'll be surprised to see that most of the test papers where you have simple questions based on absolute functions, even smartest of the kids get them wrong. As you can see from this test paper, question number 5 and question number 6. Well, they are basically based on absolute function, and I'm always surprised why students get them wrong. I'm talking about students who score 90% marks in their test, right? The 10% they lose is those basic questions on absolute function. You can see question number 8, which is based on absolute functions transformation. The student got it right. So these are smart kids, but they fail to understand basic concepts. That is why I'll concentrate more on the basic concepts. Well, if you could answer questions like this, list 3 differences between f of x equals to x squared and the absolute function, or if you know how to represent x not equal to 4 as an absolute function, or an inequality like minus 3 is x is between minus 3 and 7 as an absolute function, or if you know the answer of these questions, you may not really watch this video, as there'll be half an hour waste time for you. Now let's begin with the very first part of it, where we'll discuss what absolute functions really are and what are their characteristics. And we'll also answer our question, difference between parabola and the curve of absolute function. Absolute functions, we say they are always positive, and you've learned that absolute function could be represented as positive x if x is greater than equal to 0, and negative value of x if x is less than 0. Correct? On a graph, what do you do? Simple as that. You just sketch this absolute function with few key values, and effectively you take up a line y equals to x. Let me draw a line here, y equals to x. Correct? So this is my line y equals to x, and if you want to make it absolute function, what do? You just flip the negative part. Since you know absolute is like a distance, always positive, right? So you just flip this part, and then there you have an overlap, whatever is positive, you get your absolute function, correct? So this becomes g of x equals to absolute value of x. So what happened was you flipped this part, and that is what we mean from this statement. That when x is less than 0, on the left side on this number line of origin, then you do minus x, means reflected on the x-axis, right? So this is the x-axis we're talking about. So I think the basic concept is very clear. To give you a question here based on this, if I give you a semicircle kind of like this. Do you see this semicircle? Okay, which has been translated, let us say like this, where the points are, let's say this is minus 4 and this is 6, okay, and the top here is, well, let us say if it is 1. Now, if you have to represent this, let's say this function is f of x, and if you want to sketch a graph of g of x, which is equals to absolute value of f of x, what will you do? Well, simple as that. You're just going to flip this negative part, right? So this point, let us say, was at, because this I took as 1/4, let us say. In that case, this is going to come on this side, right? So the function will be flipped. This portion will be flipped, so you'll get it like this. however, that will remain so. So the idea for absolute function is just to make everything positive. Do you see that? So that is how we are going to represent g of x. So I think you got fairly good idea of how to represent function and their absolute values on a graph using this simple concept. So whenever the function has a negative value, for example here, it had negative value beyond, on the left side of -4, in this case on the right side of -6. So those values will be inverted, right, to get you the answer. Perfect? Okay. So that's a tips question on some test papers. Now here, let's get back to our basic question, which is absolute function and its characteristics. Now we are considering about this g of x now. So we are saying we'll call it g of x equals to this absolute function. And we can now write down these answers, which are very simple. You can write down these answers, right? All of them. Take your time, pause the video, answer them, and then it'll be time to answer the last most important question of this part of the video. Domain, as you know, x belongs to real numbers. You can put them in set notation. Y belongs to real numbers. However, y should be greater than or equal to 0. It is always positive. Intercepts. So both x and y intercepts and y-intercept are at origin, right? Let me write 0, 0, you understand. X equals to 0, y equals to 0, right? Both are at origin. Symmetry. It has even symmetry. Now this is very important to understand. What is even symmetry? Even symmetry means that g of minus x is in fact equal to g of x, right? That is called even symmetry. So what we're trying to say here, we're trying to say that if you have a point here on absolute function, then there's a mirror image right there. Is symmetric about y-axis, same distance away, right? So we say symmetric about, let me write y-axis. Do you get the idea, right? So symmetric about y-axis. This is geometrically represented as even symmetry. Algebraically, you can prove like this, okay? End behavior. End behavior is that when x approaches negative infinity, that is this part, y approaches positive infinity, going upwards. And if x approaches positive infinity to the right extreme, y again approaches positive infinity. So for both, y approaches positive infinity. Increasing and decreasing interval, it is decreasing, means you have to see from left to right. So whenever you have intervals, let me write a note here. Students sometimes get confused. Whenever we're talking about this, then check left to right. Okay, so when we say increasing interval, then it is increasing from 0 to infinity. Perfect. So for increasing interval, let me write here. Okay, I just wrote. Okay, so let me make an arrow. So increasing interval. Let me write increasing interval here. So we say increasing from, let's say, 0 to infinity. Correct. And this part, let me write a different thing, decreasing. Decreasing from where? Minus infinity to 0, correct? Minus infinity to 0. Infinity is never included, so you see these brackets, right? Okay, rate of change. Now, rate of change is a very important concept. Here, what do you see? In this interval, when it is decreasing, in this interval, what is the rate of change? It's constant, right? So rate of change in this interval is equal to -1. It is decreasing, correct? And in the other interval, when it is increasing, the slope or the rate of change is +1. Do you get an idea? Now the question is, how about at the origin? So at origin, how is the rate of change? It is undefined. Now this is extremely important to understand. Undefined rate of change at origin. You see a corner here. So the idea is corner, right? So this concept you'll use in calculus. This very important concept. At origin, what you can do is you can actually draw many tangents. See, rate of change is slope. Here one slope positive, slope is negative. How about this place? You could have 0, you could have this, you could have all these lines could be tangent at the vertex. All these lines can be tangent at the vertex, and therefore the rate of change is undefined at origin. Very important concept to understand. You can go through this concept once again, right? Now with this, we come to our critical question. List three differences between parabola. Parabola, looks like kind of like this. If this is, well, whatever, right? So we can draw kind of like this. Is it okay? A parabola, not so good, but still. So what are the three differences? Well, one of those differences you could list is rate of change. The parabola, there's rate of change. Do you see that? So what do you see? Rate of change is constant on both these sides. Constant -1, constant +1, undefined, correct? In parabola, what happens to rate of change? In parabola, x squared, it is -0 positive. Do you see that? So in parabola, it is always increasing. You see, in parabola, rate of change is always increasing, and that gives you huge difference between absolute functions and parabolas, right? You can say there's a corner at the origin, right? That could be another one. And rate of change is not defined at origin. Third one, right? So these three help you to understand differences between parabola and the absolute function. Now we'll take up inequality number line representations and how to represent them as absolute functions, right? This is a very important topic. We have seen so many questions based on this in pre-calculus courses. So what I have done here is made 3 columns for you. So we have 3 different columns. One will talk about intervals. So I'll cover up functions a bit here. Take your time. And there are a few things which I want to explain. So this is like inequality, right? X is greater than equal to -3 and less than equals to 3 is an inequality. We can represent this on a number line. We can also represent this in set notation. So these are 2 different things, but that is set notation. Is it okay? And we need to represent this also as an absolute function, correct? So I have 5 examples here. You can always pause the video, answer these questions, and then look into my suggestions, right? Okay, the first one is very simple. Let's put this number line here. Okay, so between plus and -3 means, including means if this is your -3 and if this is your +3 on a number line where somewhere in between is 0, then everything in between and including, so fill in these holes. You get an idea. Fill in these holes. And if you want to represent this as a set notation, then since you're including -3 and 3, you have to use square brackets. Is that okay? So these are all about notations. This is inequality. As an absolute function, since we are in between 2 values, the center being at 0, we just say absolute x is less than equal to 3. Perfect. Is it okay? So that is how you do it. The next one is very simple. Absolute x is greater than 2. Everybody can do this, right? So what you do here is just make an open hole here, right? So we are just concentrating on open and closed circles. So that means you are either on left side of -2 or right side of 2, nothing in between. That's what it means, right? So you can understand both these very clearly. And here, since there are two parts, we'll say x is less than minus 2, or could be represented as or union, that is x is greater than 2. Perfect. So simple as that. Now when we say x belongs to real numbers, it find how to write it in interval notation. Well, or an inequality. Let me write this as an interval notation. So all real numbers means from minus infinity to, to plus infinity, right? You can never include infinity. But how do I write this as an absolute function? That's a great question. Think about it. If I write absolute x is greater than minus 1, will I get all real numbers? Since absolute x is always positive, always it is going to be greater than minus 1. Yes, so that's true. I could also say for this another example, absolute x is greater than equal to 0, right? That's its range. So it is range. Range is all real numbers. You get an idea, right? So these are good examples. Now we have some tough ones. Now, these are really difficult questions. You can actually now pause the video, answer these two. So I treat them as most difficult questions based on this particular topic. How do we get the answer for these? So let's look into the number line first, easy part. So we know we're looking into something which is in between minus 3. Let's say this is minus 3 for us. And this is 7 for us. So we are looking for something in between minus 3 and 7, and we have to write this as an absolute function. How do we do it? Now this is key to understand absolute function. Absolute function is deviation from the center, how far you are from a point, right? So think like how far, let me write here, how far are you from a point? That is the basic concept for absolute function. Do you understand? How far are you from a point? Extremely important. So how do you find? You find the midpoint of this. So what you do here is you find the midpoint. So what we do here is find midpoint. This is first step. So midpoint here is add them up, minus 3 plus 7 divided by 2. That is 4 divided by 2 is 2. So the midpoint is at 2. Now answer this question, how far are you from a point? That is to say, how far are you, what is the distance from here to one extreme and what is the distance from here to the other extreme? Obviously, since this is a midpoint, both distances are same. The distances here are 5 units, correct? 5 on this, 5 on this. Center being at 2. Do you get it? Now, can you pause the video and answer your question? Yes, of course. It is absolute value of x when it is transformed or translated 2 units to the right, minus 2. And you are within a range of 5 units, less than 5. We are not including these since they are open circles and it's like less than, not less than, equal to. That is your solution. You get an idea, correct? Right, and now we have another extremely important question. In set form, we want to represent x belongs to real number, x is not equal to 4 as an absolute function, not equal to 4. Okay, first write this as an interval notation. Can you do that? That's also tricky, man. So you could say that x is less than 4 and x is greater than 4. Well, one way could be this, which you could also write as minus infinity to 4, don't include it, union 4 to plus infinity. So that is done. How do you write this as an absolute function? Correct? That is what you have to do. On a number line, you can represent this as a whole, add 4 and extend both sides. Does it make sense to you? Now these are important part also. How do you represent this as an absolute function? That's a key question. Now let's get back to this concept, get to 4. To get to 4, I have to translate 4 units to the right, correct? And if I say all values except 4, then I could say this is greater than 0. So if I write 4 here, it gives me 0. So 4 is not a solution of this particular inequality in terms of absolute function. Do you see that? Now I'll discuss inequalities and equations of absolute functions in details in part 2. However, you got a clue how important it is to understand these concepts, right? So definitely look into my part 2 also if you want to really understand how to work with absolute functions, and especially if I involve 2 of them together, it becomes even more complicated, right? So it's a very important video for all those students who are going to take calculus and taking AP maths or such things, right? Now here is one of the most popular questions which I asked, and I have many videos on this actually with lots of hits. What is square root of x square? What is square root of x square? Most of the questions students will say that is equal to x. And this answer is incorrect. This answer is incorrect. So if if square root of x square is not equal to x, what is it equal to? This is very interesting. Many different ways I could show you what is this equal to, which you can see in details in some of my videos. So what we will do is we'll take up some values of x and see what is square root of x square. So if I write x as 0, I know 0 square is 0, just 1. 1 square, 0 square root is 0, right? For 1 we get 1, right? 1 square is 1, and this. If I write 2, well, 2 square is 4, square root of 4 is, let me write here. So 2 square is actually square root of 4, which is equals to 2, and 3. So if I write 3, 3 square is 9, and that is 3. But what happens if I write minus 1? So if I write minus 1, I write here minus 1 square, which is positive 1. I get positive 1. I do not get x. I do not get x. Do you get the concept? If I write minus 2 here, square root of minus 2 whole square is 4, and square root of 4 is 2. Perfect. So what we see here is always a positive number. What we see here is always a positive number, right? A positive number. So what do we conclude? You got it. Absolute value of x. So square root of x square is indeed equal to absolute value of x. Does it make sense? Does it make sense? Well, some students could actually see it the other way. They're good at arts, right? So what do you see? This is what? This is square root of x. Do you see that? Always positive. If I do that, then what happens? I should get all positive values, no? I should get all positive values. All positive values. Does it make sense? Why am I writing like this? I want to create an impression on your mind that square root of x square is indeed absolute value of x and not x. Since x belongs to real numbers, it could be negative also, right? X is the whole line. Do you understand? We have to only represent this part of the line. This part of the line. So the range has to be greater than or equal to 0, which is that of absolute function, right? So I hope this point is well taken care of. Let's move on. Okay. Now let's graph absolute value of x divided by x. Perfect. Absolute value of x divided by x. How do you graph this? Well, the best way to graph this is rewrite the function. So what is absolute value of x? Absolute value of x is x. So we could write this as x over x for x greater than or equal to 0. And we could write this as minus x over x when x is less than 0. Correct? That means what? That really means that f of x is equals to x over x is 1 when x is greater than or equal to 0 and minus 1 when x is less than 0. Correct? Correct. Now in doing this, I made a mistake. Now your question, that is also a test question, right? The question is, find my mistake. Right there, we have done a mistake. Find my mistake, right? Now, that's another very important question to understand. The mistake is on the restriction of this function. You see that? The mistake is that x cannot be equal to 0, since you cannot divide by 0. Do you understand? So I'll rewrite, of course. So this is wrong. This is wrong. So I have to rewrite this. So I'm writing with correction. X is greater than 0 or x is less than 0. Here also I'll say x is greater than 0 and x is less than 0. It cannot be equal to 0. Perfect. Once I know that, then I draw a correct graph, right? So I hope you've understood how that mistake happened and how we got it right in time, right? Otherwise, I'm sure many of my subscribers would have got me, right? As they do most of the time, right? So the function which we are saying is absolute value of x over x. X is not equal to 0. Sketch it. Pause the video, sketch this function. Okay, then check. Don't make a mistake this time. I've already told you the mistake which I made. So we have at 1 a line which moves forward and a line which moves backward. It means constant, right? This value is minus 1, this value is 1. The correct graph will be, you have to open circle, add this up. Open circle here. Now this open circle at origin, x equals to 0, represents this part and this part. We are not including 0, right? So here, our domain is x belongs to real numbers where x is not equal to 0. Now this is very important part, and that's why I'm talking about it again and again. I hope it's well taken care of. Feel free to write your comments, share my views and your views on this topic. Let's move on. Now we are almost at the end of this video. We'll discuss transformations. You can actually pause the video, answer this question, and then look into my solution. So we look into transformation of a function. Let me rewrite this function as g of x equals to 4 minus. Within absolute function, we have 2x minus 6. And we are comparing this transformation with respect to the parent function of x equals to absolute x, correct? So you need to describe this transformation. At the end of the video, we'll also discuss how to graph, let's say a function h of x equals to 2 to the power of some absolute function. So we'll just take x minus 1, okay? So that could be your test question after this. Okay, so I hope you must have got your transformations listed. when I do these questions, I like to rearrange this equation in the form which is very familiar to me. So I prefer first step to factor out this 2. So if you factor this, you get x minus 3. It is extremely important so that you understand that the horizontal compression is by a factor of half and translation is 3 units to the right. Perfect. It's even better to write this equation as minus first 2x minus 3 plus 4. Since that is the way normally we see transformed equations. You get an idea, right? So let me list the transformations now. Okay, one by one. So we'll start from left to right. So you could actually write, in fact, you should always write multiplication things, which is stretches, compressions, and reflections first, and then translations, right? So this means reflection on. So it is y-axis, like going up and down. So it's a reflection on x-axis. Do you see that? It's up and down. So both these are vertical. Both these are vertical. Inside it is horizontal. So 2 represents horizontal compression by a factor of half, 1 over k, right, by a factor of half. And then we come to translation. You could even combine them together, or you may write translate 3 units, right, not 6, and translate 4 units up, correct? So that becomes the complete description for transformations of this function. And what you can do is you can kind of sketch this function. For sketching the function, some of my students believe in taking key values and then do it. So, but what I will do here is kind of do it in 2 steps. So what we have here is, this is my absolute function. So I'm not making a scale here. So first step is to reflect. So when I reflect it, I get this kind of a thing, correct? And then it is horizontally compressed by a factor of half. What does that mean? And how to show it on a graph? This is what I want to teach you. So this point, let us say it is at -1, right? -1. Stretch horizontally compressed by a factor of half means bring it halfway inside. So at this point, let's say it's at -2, bring it halfway inside. Do you see that? That is compression. This is this part. And then join it, right? So let me take another ink and then join it. So basically at this stage, we're talking about that kind of a figure, right? So as you can realize, we had minus absolute x at that stage, and now what we did was we compressed it horizontally, correct? So when you compress it horizontally, then it becomes this. Is that okay? Now after this, we have to translate 4 units. You could do 4 units up, let's say 1, 2, 3, 4, and 3 units to the right. So 1, 2, 3, correct? So it comes there. And then you just sketch this function. So let me just make it with some other ink. Okay, so just sketch. I'm not sure where the x and y intercepts are for the time being, but it may be a good idea. Let's see. So the question for you is, find x intercept and y intercept. So that is an exercise for you. You understand x and y intercepts. If I substitute 0 here, what do I get? I get 4 minus 6, which is -2. So this graph will go through -2, right? So I could now sketch this using this information. Do you get an idea? And this point is, for me, 3. Okay, so this point for me is 3 towards the x and 4 up. Do you see that? So that is my vertex. That is my vertex v. Okay, so that's my final graph for the absolute function. And to get it accurately, it's a good idea to find x and y intercepts. Y-intercept is simpler since you just substitute 0 for x. Y-intercept means x equals to 0. An easy calculation, correct? Okay, now a thinking question for you, which normally you will see in tips. Graph 2 to the power of absolute value of some function, right? Which is simple in this case, taken as absolute x minus 1. Is it okay? So normal graph for 2 to the power of x is kind of like this. This is 2 to the power of x. Now, if I write something here, of course this means translating 1 unit to this side. Is it okay? But after that, before that, we have to do this part. Absolute means what? Absolute means that x values are always positive, right? So even if I write the negative values, for minus 1, it is going to be 0, right? Minus, it'll give me positive value. So basically, it gets reflected. Do you see that? So here, all these negative values will give you a positive result for absolute x. And then you move 1 unit to the right. Do you see that? So finally, you will get a graph which will have a vertex here, kind of. And it will be like this. Do you get an idea? Is it okay? Right? So it gets translated. You can, of course, make a table of values. You can make a table of values for some values of x. For example, good values will be minus 2, minus 1, 0, 1, and 2. And then calculate 2 to the power of absolute x minus 1, plug it in, get your graph, right? So if I write 1 here, 1 minus 1 is 0, and anything to the power of 1, anything to the power of 0 will be 1. So that point represents 1, 1 for me. Do you see that? Correct? So if I write 0 here, then it is to the power of 2. So this point represents 2 for me. That is how you're going to sketch it. I hope you find it important and interesting. Thanks for watching my video. Feel free to write and share your comments.